Hey there guys, probably you already know how to solve for the probability of simple events. Now let's dive into the probability of compound events. And one of the topics there is the probability of mutually exclusive and non-mutually exclusive events.
Minus 2 pi minus 3, 6y, you end up with 5x plus 2.
When we say mutually exclusive events, these are events that do not have the same elements, or these are events that cannot happen at the same time. Example, if we are going to roll a die, getting a 3 and getting a 2, they are mutually exclusive because they cannot happen at the same time. Okay? You cannot have an outcome that is both a 3 and a 2. Another example, if we have the standard deck of cards, getting a black card and getting a red card is mutually exclusive because we cannot have a card that is both a red and a black. Okay? Walang card na red and black at the same time. So how then do we solve for this kind of probability? Okay. The probability of two mutually exclusive events is found by adding the probability of each event. Okay, so the probability of event A or event B is equal to the probability of event A plus the probability of event B. Okay, so remember this conjunction. It uses the word or. So let's have an example. A card is drawn at random from a standard deck of cards. What is the probability of drawing a queen or a queen? Okay, I'm sorry, that should be or. And of course, drawing a queen and drawing a king, they are mutually exclusive because there is no card that is both a queen or a king. Okay, so we use a formula. Okay, so the first thing we're going to do is to get the probability of the first event. Okay, the first event is that when you will get a queen, and there are 4 queens in a standard deck of cards. So that will be 4 over 52, since there are 52 cards all in all, plus the probability of getting a king. Okay, so there are also 4 kings. 4 over 52 is the probability of getting a king. Now after that, we're just going to add. And the rule of adding fraction is that if we are adding fractions with the same denominators, just copy the common denominator and add the numerator. So 4 plus 4 is 8. The final answer is 8 over 52, or we can still simplify this to 2 over 13. All right. Okay, so next example. A box contains 4 red balls, 5 green balls, and 3 blue balls. Helen draws 1 ball at random. What is the probability that the ball is either green or red? Okay, so always remember, if it's or, addition is involved. Okay, so that is also a case of mutually exclusive because we cannot have a ball that is both a red or a green. So the first thing we're going to do is to get the probability of getting a red ball. And since there are 4 red balls, 4 will be the numerator. And for us to get the denominator, we have to add all these things. So 4 plus 5, 9 plus 3 is 12. So there are 12 balls in the box all in all. So the probability of getting a red ball is 4 over 12 plus the probability of getting a green ball. So 5 green balls out of 12 balls in the box. And the rule of adding fractions is that if they have the same denominator, just copy the common denominator and add the numerators. So 4 plus 5 is 9. And as you can see, we can still simplify this fraction, and so the final answer is 3 over 4. So the probability of getting a red or a green ball from that box is 3 over 4. So I hope you already know the idea of mutually exclusive events and how to get its probability. Now let's go to non-mutually exclusive events, or in some books they call this inclusive events. Okay, so these are events that have outcomes in common. Okay, example, in a standard deck of cards, getting a red card and getting a heart card They are example of non-mutually exclusive events or inclusive events. There is a card that is a red and a heart at the same time. Okay, the same. We have to add the probability of those two events, but then we have to subtract the probability of the event where they have common elements. Okay, let's have an example. A card is drawn at random from a standard deck of cards. What is the probability of drawing a king or a red card? You see, drawing a king and drawing a red is an example of non-mutually exclusive events because there is a card that is a king and a red at the same time. Okay, so how then do we solve for this one? Okay, since we are looking for the probability of king or red, we are going to add them, but then we have to subtract the intersection or the probability where they have common outcomes. Okay, so first we get the probability of getting a king, and that is 4/52. Getting a red, on the other hand, in a standard deck of cards, half is black, half is red, right? 52 divided by 2 is 26, so there are 26 red cards out of 52, minus the probability of king intersection red. What does this mean, okay? So to get the numerator of this probability, we just have to count kung ilan yung card na king at the same time red. So isipin mo sa card, there are two red king cards, okay? Yun yung King of Hearts and King of Diamonds. So since dalawa, yun yung ilalagay natin dito. Okay, so saan ko ulit kinuha yung 2 na to? Ito yung bilang ng cards na both king and red. Dalawa sila because those are the King of Hearts and King of Diamond. Okay, so that is 2/52. Okay, so since they have common denominator, we copy the common denominator and we just have to add or subtract whatever is in the numerator. So 4 plus 26 is 30. 30 minus 2 is 28. So the probability of getting a king or a red card is 28/52. But still, we can simplify this. And so the final answer here is 7/13. You see, we can write probabilities in fraction or in decimal or in percent. Okay, last example. A die is rolled. What is the probability of getting a 2 or an even number? Okay, so getting a 2 and getting an even number is non-mutually exclusive events. They are inclusive because 2 is also an even number, right? We will be getting the probability of getting a 2 since there is only one 2 in the die, that is 1/6, plus the probability of getting an even number. There are 3 even numbers, so that will be 3/6 minus, okay, this is what you're going to look into, the probability of 2 intersection even. Okay, so there are 3 even numbers. Yung 3 na even numbers na yun ay 2, 4, 6. And we have here another outcome, which is 2. Okay, so this is the intersection, and we only have 1, 2, which is an even number. Okay, so actually the intersection of 2 and even is 1/6. Nag-iisa lang naman kasi si 2, di ba? Okay, so then we copy the common denominator. We add the numerators. 1 plus 3 is 4. 4 minus 1 is 3. And so that is 3/6. We can actually simplify that to 1/2. Okay, so the final answer here is 1/2. The probability of getting a 2 or an even number in rolling a die is 1/2 or 50%. So that is how we solve for the probability of mutually exclusive events and non-mutually exclusive events. If we solve for mutually exclusive events, we just have to add them. Kapag non-mutually, we have to add and then we have to deduct the probability of their intersection or the probability of the event where they have common outcomes. Okay, so see you guys in the next video.